Hi, welcome to Introduction to Statistics. In this video, we're going to be talking about the addition rule of probability. So thus far, you should understand the following. Probability is the measurement of the likeliness of an event occurring. You should know how to calculate basic probabilities. You should know basic notation of probability. Um, Also know how to visualize a probability using a Venn diagram. And you should also know that probability ranges from 0 to 1, where a probability of a 0 means the event is impossible, and a probability of a 1 means the event is most certainly going to happen. So any probability for an event that is close to 1 means that it's very likely to occur. Any probability of 0 for an event means that it's very unlikely to occur. In this video, we're going to be talking about compound events. A compound event is any event combining two or more simple events. And the notation that we use for compound event is the probability of event A or B, which means the probability that event A occurs or event B occurs, or that both event A and B occurs. So we're going to be using some examples here involving decks of cards. So just if you if you don't know what kind of cards are in a deck of card, a standard deck of card, we have the following. So we have four different suits. The first row here is the clubs. This suit is the hearts. These are the spades. These are the diamonds. And within each different suits, there are 13 different cards. So we have ace, and then the number cards all the way to 10, and then the jack, the queen, and the king. These three are what we refer to as the face cards. So 3 face cards for 4 of the suits. So we have a total of 12 face cards. So say we have a standard deck of cards, and say after a thorough shuffling, what is the probability of picking a 5 from the deck of cards? Well, let's see. In our Venn diagram, our sample space contains 52 total cards, and there are 4 cards, 4 fives for each of the different suits. There's 4 suits, and each suit has a 5, so we have 4 fives. So the probability that we pick a card in, it's a 5. There are 4 ways we can do that over a total of 52 cards. So if we reduce this fraction by dividing by 4, we get 1 over 13, which is approximately 0.0769. Okay, so second question, this one involves a compound event. So after a thorough shuffling, what is the probability of picking a 5 or a heart from the deck of cards? So this is the probability that we pick a card, and that card is either a 5 or a heart or a 5 or both, a 5 and a heart. Okay, so our sample space contains 52 cards. There are 4 fives and there are 13 hearts. But there's one card that is both a 5 and a heart, and that is the 5 of hearts. So when calculating this probability, we know that the denominator is 52 because that's the total number of outcomes. There are 4 fives plus the 13 hearts. However, because we double counted the 5 of hearts, right? We double counted when we were considering the fives, and then when we were considering the hearts, we counted it twice. You always have to subtract that the number of values you double count. In this case, there's only one card that we double counted, which is the 5 of hearts. Okay, so if we work this out, we get 16 over 52, reduces to 4 over 13, which is approximately 0.31. Okay, so we can generalize this idea. We can generalize this by breaking this fraction apart, and we get that the probability of picking a 5 or a heart is equal to the probability of a 5 plus the probability of a heart minus the probability of picking a 5 and heart. Again, that a 5 and a heart would mean that there's only one way that can occur, and that is if we pick the 5 of hearts. Okay, so if we generalize this, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And this is what we call the addition rule of probability. It's very important that you understand that the addition rule of probability only applies to single trials. Uh, Later on, we're going to be talking about the multiplication rule, and the multiplication rule of probability applies for multiple trials. So just kind of keep that in mind. So let's look at this example here. Actually, let's go back to this. And I want to, again, re-emphasize something that's very important. The addition rule applies to OR probabilities for when you have a single trial. So remember that. So whenever associate the word OR when it comes to probability with the addition rule. Addition rule, again, OR for a single trial, associate with the addition rule of probability. In the next section, you're going to be learning about the multiplication rule. And the multiplication rule applies to AND probabilities, again, for multiple trials. It's got to be multiple trials as well. Whenever you have that situation, an AND probability with multiple trials, you're going to be using the multiplication rule for a probability. All right. So again, more on that in the next video. Let's go ahead and look at this simple example to try to make sense of the addition rule. So in this case, we have in a bag, there are 23 red marbles, 29 red jacks, 15 blue jacks, and 18 blue marbles. If someone reached in a hand to select an item from the bag, what is the probability of picking a jack or a blue item? Okay. So we're trying to find the probability of picking a jack or a blue item. This is an OR probability in a single trial because we're selecting an item, which is, again, a single trial. Which means we would, one way to solve it is using the addition rule. So the addition rule says the probability of picking a jack or a blue item is the following. So that's equal to the probability of picking a jack plus the probability of picking a blue item minus the overlap, the probability of picking a jack and a blue item. And notice that we have, let's see, 29 plus 15, that gives us 44 different ways we can select a jack out of 85 total items. Again, 85 we can get if we add up all of these values, to get a total of 85 items, plus the probability of getting a blue item. So blue item are these guys right here. So 15 plus 18 gives us 33. 33 different ways we can select a blue item out of a total of 85 outcomes, or items in this case. However, there's a problem. We double counted the blue jacks. We count the blue jacks when we were considering the jacks, and then we counted it again when we were considering the blue items, which means we have to subtract the items which are both blue and jack. So the probability of getting a blue and a jack, well, there are 15 blue jacks out of 85 total items. So let's work this out. This is applying the addition rule. So if we work this out, we're going to get the following. We're going to get 62 over 85. 62 divided by 85 would give us approximately, if we round this to 4 decimal places, 0.7294. So let's do one more example. So in this example, we have the following. It says the following data summarizes results from 888 pedestrian deaths that were caused by accidents. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was intoxicated or the driver was intoxicated. So we have a table here. So this is a two-way frequency table. So it's very important that we understand how to read this table. For example, this column is the number of deaths where the pedestrian was intoxicated, and this column is where the pedestrian was not intoxicated. This row, this first row here, is where the driver is intoxicated, and this row here is where the driver was not intoxicated. So again, these are deaths. Each of these numbers are counting deaths, and this column is relating to whether the pedestrian is intoxicated or not. The rows are related to whether the driver is intoxicated or not. So for example, let's take a look at this 60. 60 of these deaths involved a pedestrian that was not intoxicated and involved a driver that was intoxicated. Let's look at another number. So for example, this 223. So this is where the pedestrian was intoxicated and the driver was not intoxicated. So hopefully you guys can see that. It's the intersection of that row and column, which is the row where the pedestrian was intoxicated and the driver was not intoxicated. All right, so once you figure that out, or once you understand how to read this table, that's kind of half the battle in answering this problem. So the question, going back to the question, it says, what is the probability that we select one person, right? We select one of the pedestrian deaths such that the pedestrian was intoxicated or the driver was intoxicated. So if we consider this is an OR probability, which means we can use the addition rule of probability. So this is the probability that the pedestrian was intoxicated, oops, or the driver was intoxicated. According to the addition rule, this is equal to the probability that the pedestrian was intoxicated plus the probability that the driver was intoxicated, subtracting the overlap. So in other words, the probability that the pedestrian was intoxicated and the driver, I'll just put DR period, driver was intoxicated. Okay, so let's figure those out. So how many different ways can we select a death where the pedestrian was intoxicated? Well, let's see. Notice how this is the pedestrian intoxicated column. So there are 90 plus 230, 223. So there's a total of 313 deaths where the pedestrian was intoxicated. So we have 313 different ways of selecting a death where the pedestrian was intoxicated out of a total of 888. Again, that total was given to us right here. Plus, how many different ways can we select a death where the driver was intoxicated? Well, let's see. This is the row where the driver is intoxicated, so that's 90 plus 60. So there is a total of 150 deaths where the driver was intoxicated out of 888. So let's kind of visualize this. So we have the pedestrian intoxicated, the driver intoxicated. So notice if I write this or draw this visually, notice how we circled 90 twice? We're double counting 90. In other words, that's the overlap. That is the pedestrian being intoxicated and the driver being intoxicated. That's why we have to subtract that number out, or that probability, because we're double counting it. Okay, so subtract the probability of the pedestrian being intoxicated and the driver being intoxicated. Well, that's the 90 that we circled here, right? We double circled that. Pedestrian was intoxicated, driver was intoxicated. Okay, so let's work that out. So we get 373 over 888. Instruction says to round to 3 decimal places, which means we're going to turn this into a decimal by dividing 373 divided by 888, which is approximately 0.420. Okay, so hopefully that was helpful. Again, as always, if you have any questions, let me know.